Okay, good morning all. Today we are going to cover lesson 5.4 on complex numbers. And so you're going to be able to simplify a radical into a complex number. Now, what complex numbers are, actually people kind of misunderstand these things. All the numbers can be contained in a box like this. We're just going to create this chart to sort of symbolize all the numbers in the number system. So falling within this number system are what we call the real numbers. And the real numbers are all kinds of numbers that we're used to using. So it could be -2, it could be the square root of 5, it could be 3/8, it could be negative square root of 7. It could be any of those things, or it could even be pi. Okay, those are all real numbers, but all of these numbers are part of a subset called the complex numbers. And the complex numbers include a part called the imaginary numbers. So imaginary numbers are, well, frankly, the imaginary number is the square root of -1, which is I. We call that I. And we'll talk about how that works. When we look at them as a complex number, we use a real number plus I. So the number 4 plus 3I is a complex number that has an imaginary component in it. Or 8 plus 7I. Or for that matter, you could have the square root of 5 plus 6I. Those are all examples of complex numbers. That is, numbers that have a real number component and an imaginary component. Okay? All right, so now we've got to understand how we get to it. So just remember again, before we get to that, this is going to support IXL skill I1. You're going to put your header on your notes. You're going to take notes on this as you always do. You're going to upload them to me by Saturday. All right? All right, so to understand why we have this imaginary component, we need to go back and look at how we factor and solve. So this is a good example of a factoring situation. And so we're going to go ahead and just factor it like we did in Unit 4. So we create our double bubble, and we have x squared, so that means we've got first and first, or x times x. And then -25, well, that's got to be positive and -5. So plus 5 minus 5, and that all equals 0. And if you remember, what we would do with that is we would take out these two terms, x plus 5, make that equal 0, and x minus 5, and make that equal 0. And of course, the 5 would go over here, the -5 would go over here, but you're subtracting 5 from both sides. So this is x equals -5, and over here you're adding 5 to both sides. So this is x equals 5. And so you were able to factor this successfully and find out what x is when y equals 0. But this is almost the same, but we can't factor this. Why? We can't factor it to get what we got over here. So let's just try to do double bubble, and so x plus 5 and x plus 5 is what it seems to be, right? But if we split this up, if we try to multiply this back together, what we're going to find out if we multiply it back together is x times x is x squared. And then I have x times 5 is 5x, and 5 times x is 5x, and 5 times 5 is 25. So you see, we end up with something completely different. X squared plus 10x plus 5, or plus 25, equals 0. A totally different problem. So to deal with this, mathematicians invented I. So what is I? What they did was they said let I equal the square root of -1. Okay? And so using this, they were able to actually take care of the situation here that did not work, right? This did not work. And we're able to factor things that have a negative in them when we are going through these. So we're going to see how this works. Okay. All right. So here's the first one that we've got here. And this is the square root of -16. So there's a negative sign under the radical. That's the problem. And we want to be able to get rid of that. Well, we factor that into the square root of -1 times the square root of 16. And when we do that, we know that the square root of -1 is I, and the square root of 16 is 4. So we end up, when we finish this off, we always want to put the real number first. So this is the imaginary number that we have. So it allows us, again, this square root of -1 issue. If you multiply the square root of -1 times the square root of -1, you get -1. We'll get into that later at a different time. But dealing with that conundrum and that issue, we just set it up this way, and we have the offending part, the square root of -1, showing as I. Okay. All right, let's look at this one over here, B. Here, let's take care of the square root of -25. So that's the square root of -1 times the square root of 25, right? And then we have this negative sign that comes down as well. The square root of -1 is I. Square root of 25 is 5. And we are going to reverse those to put it into standard form, and we're going to bring down the negative sign. And so we end up with a negative, with the answer of -I, or -5I. Sorry about that, -5I. Okay. All right, and then the next one here is the square root of -15. Now, when we look at this one, again, we'll take out the square root of -1, but then we've got the square root of 15. Now, remember, 15 is not a perfect square. It's 3 times 5. So, because of that, we're just going to have to we're going to have to figure out what to do with that. And so there really isn't anything that we can do with that. So we change the square root of -1 into I like we did before, and we just leave the second one as 15. So this is I square root of 15. That's all we're going to do with it. All right, and on D over here, let's deal again with what's under the radical sign. So square root of -18 is the square root of -1 times the square root of, well, let's see, 18, 6 times 3 is 18, 2 times 9 is 18, okay, so we could factor this into square root of 9 times the square root of 2, right? And so that would roll up to square root of 18, right? And don't forget, we're going to bring down this negative sign. Okay, so we've got I here times square root of 9 is 3, and the square root of 2. Okay, so now let's just put this in an order. We want to put the real component first. So we're going to list that first, and then we've got the negative sign out front. So -3, and then we have the I, square root of 2. All right. So that's how we set these up into standard form for a complex number. Okay. Let's do a few more. So these are a little more complex. We've got a real number component already. We have a negative sign and we have the square root of negative 6. So let's deal with the square root of negative 6. So that's the square root of negative 1 times the square root of 6, which is 2 times 3. We really can't do anything with that. So we're just going to have to leave that as the square root of 6. All right? And then we have this negative sign out front in the 3. So let's clean that up a little bit. So that means we have 3 minus, and then this is I times the square root of 6. And that is an acceptable number. It's in what we call complex order. So it has a real component and it has an imaginary component, right? This is the imaginary component, this is the real component, and together these form a complex number. Okay, complex number. All right, and so then let's look at f here. So we have, again, 6 minus the square root of 49. So let's deal with what's under the radical sign. So that's the square root of negative 1 times the square root of 49. And then we have the 6 and the minus that we bring down. The square root of negative 1 is I. Square root of 49 is 7. We have the 6 and the negative sign. So what we want to do here is change the around the 7 and the I. So it's, let's see here, 7 actually should go first. Oh, no, wait. Let me just look at this a second. No, this is this just needs to be reversed. So it's 6 minus 7i because the 7's multiplied to the I. And so this is our answer. Okay. Again, another complex number. Imaginary component is right here, and the real component is right here, and together they form a complex number. All right, G. Let's see, we've got two radicals. Let's just deal with them first. So square root of negative 45 is the square root of negative 1 times the square root of, let's see, 9 times 5. Oh no, let me see, 45 is what? 45, yeah, it's 9 times 5. So square root of 9 times the square root of 5. And then we have a negative sign here. We got the square root of negative 80, so that's negative 1, square root of negative 1 times the square root of, what is 80? 80 is, let's see, 80 is obviously, I mean, we could do 10 times 8. Can we divide by 4? Let's get my calculator out. So 80 divided by 4 is 20, which is 5 times 4. Oh, there's a 4 and a 4. So 4 times 4 is 16. So if we take 80 and we divide it by 16, we get 5. So 16 times 5 equals 80. Square root of 16 times the square root of 5, right? All right. And then we have the 4 plus out here, okay? So square root of negative 1 is I, okay? So 4 plus I. Square root of 9 is 3, so times 3. And then the square root of 5 comes along for the ride. All right, looks like we want to reverse the I and the 3. So we would write this as 4 plus 3i square root of 5. So that part's taken care of. And then over here I have negative sign coming down. This is I. This is 4 times the square root of 5. So that would simplify as negative 4i square root of 5. Now, I've got 3i square root of 5 minus 4i square root of 5. So that simplifies, and notice this is 4 plus this minus all of this. So there's really three terms connected by a positive and negative sign. So I can combine the 3i square root of 5 with the negative 4i square root of 5. That leaves me with negative 1i square root of 5, right? And then the 4 comes down. And so that's our answer. It's all in standard form, real component, an imaginary number over here in the component. So again, that's in the a plus bi format. Okay. All right, and you don't need to have the 1 here if you don't want to. You could have said 4 minus I square root of 5, and that would have been considered fine too. All right, square root of 49, well, that's easy. That's 7. Minus, now this negative square root of 49 is the square root of negative 1 times the square root of 49, which is really 7, isn't it? Yeah. Well, let's use square root of 49 just to be good citizens here. So bringing this down, I have 7 minus I, and then this is times 7. And then let's switch this around again. So if this is really 7 minus 7i, we just reverse the multiplied I and 7. And so again, this is now in standard complex form. So bottom line is, you've got to remember I equals the square root of negative 1. All right? That's the big takeaway from all of this. And we're going to be using that to add, subtract, multiply, and divide as we go along with this. So that's it for today, ladies and gentlemen, or at least for this day, this particular lesson. So thank you very much. We'll talk to you later.